The intern hit deploy. Minutes later, chaos. Alerts exploded. Slack was on fire. Engineers flooded the incident channel. The issue? No staged rollout. The intern pushed the update to 100% of users at once, skipping all the Canary testing before prod. The result? Database connections maxed out, and the app's response time spiked to 10 times the normal amount. And the intern stared at his computer blankly, still hoping for that return offer. But was it really their fault? Or was this disaster bound to happen? The truth is, without a proper rollout strategy, even the smallest change can bring everything crashing down. So how do we prevent this intern from breaking prod? The answer is rollouts. A rollout is the controlled process of deploying software updates, patches, or new features to production environments. Instead of releasing a new version to all users at once, rollouts help minimize risk by incrementally exposing changes to different segments of users. This allows teams to monitor performance, detect issues early, and quickly roll back changes if necessary. So a rollout strategy limits the blast radius of potential failures, enables reverting back to a previous stable or golden version if issues arise, reduces downtime by gradually updating components rather than performing a full system-wide update, and also supports A/B testing and feature flags, which means testing different versions with specific user groups before full deployment. Now we're going to cover a couple key deployment strategies, starting with the blue-green deployment. Blue-green deployment is an application release model that gradually transfers user traffic from a previous version of an app or microservice to a nearly identical new release, both of which are running in production. The old version is the blue environment, while the new version is the green environment. Once production traffic is fully transferred from blue to green, blue can stand by in case of rollback, or be pulled from production and updated to become the template upon which the next update is made. You start by setting up two identical environments. Blue is currently the live production environment, and green is a staging environment where the new version is deployed and tested. And then you deploy the new version to the green environment, so the green environment runs the updated software, and internal teams and automated tests validate the new release. Once validated, all incoming traffic is rerouted from the blue environment to green, and this transition is usually managed via a load balancer or DNS switch. The final step is to monitor the new deployment, so if issues arise, traffic can be quickly switched back to blue using a rollback. The green environment is now the active production version. There's a couple advantages to this. You have zero downtime since traffic is switched instantly and users experience no service disruption. There's also an easy rollback mechanism to switch back to blue. It also supports testing in a production-like environment because the green environment can be tested very rigorously before going live. The main downsides is that you have very high infrastructure cost because you're maintaining two identical environments at all times. It also makes database migrations quite complex because if schema changes are involved, both environments must be compatible. And finally, blue-green is not very suitable for high-frequency deployments because maintaining two versions simultaneously can be very inefficient for rapid updates. If you are interested in taking your software engineering skills to the next level, I would encourage you to build projects. I'm not talking about going down the rabbit hole of tutorial hell and building a to-do list, calculator, or weather app. I'm talking about building complex, real-world projects beyond the basics. And this is where CodeCrafters comes in. This platform provides interactive tools to build developer tooling from scratch. There are a number of courses that teach building Git from scratch, building an in-memory Redis database, an HTTP web server, your own Docker, your own DNS server, and many others. I personally love that there is built-in support for over 20 different languages. My favorite, of course, is Golang, but I would highly recommend trying a newer language like Zig as well. I'm excited to announce that I'm partnering with CodeCrafters to offer all my viewers 40% off. For more details, you can find a link in the description down below as well as the pinned comment. Next, we have Canary deployment. A Canary deployment is a progressive rollout of an application that splits traffic between an already deployed version and a new version, rolling it out to a subset of users before rolling it out fully. This allows teams to monitor real-world performance and detect issues early on. You start by deploying the new version to a small group of users known as the Canary group. And this Canary group could be based on random sampling, geolocation, user type, or other criteria. Then you want to monitor performance, logs, and user feedback. So in the Canary group, you want to monitor things like RPC errors, response times, error rates, and throughput to ensure that the new version performs as expected under real conditions. By comparing the control or the old version versus the experiment or the new version, you can catch issues like service degradation or increased latency before they affect everyone. If any issues arise, you just roll back before broader impact. And the final step is to gradually expand the rollout in stages, known as a staged rollout. So if this Canary deployment is successful, more users receive the update in stages. And this process continues until the new version is fully deployed. There's a couple advantages here. For example, you're only impacting a small subset of users initially, you get real-time monitoring, and you also are able to catch performance bottlenecks before a full rollout. Because we have a staged rollout, this full rollout process takes longer compared to blue-green. And teams also have to have very robust observability and monitoring tools. Because of this staged rollout process, some users are experiencing different versions during the rollout. The third strategy is a rolling deployment. A rolling deployment is a strategy where the new version is deployed incrementally across different instances or servers, replacing the old version in stages. This is effectively replacing the infrastructure on which the application is running. For example, in a rolling deployment in Amazon Elastic Container Service, containers running previous versions of the application will be replaced one by one with containers running new versions of the application. A rolling deployment is generally faster than a blue-green deployment. However, unlike a blue-green deployment, in a rolling deployment there is no environment isolation between the old and new application versions. This allows rolling deployments to complete more quickly, but also increases risks and complicates the process of rollback if a deployment fails. And this is because a subset of instances are already updated. There's also some temporary version inconsistency, as some users may be served by old instances while others use the newer version. The main benefit here is that unlike blue-green, there's no need for duplicate environments. So how does this work? In a nutshell, you begin deployment on a small subset of instances. A few servers or containers receive the update while others continue running the old version. You monitor system behavior and performance. If errors occur, the rollout is paused or rolled back. And then you continue rolling out in batches until all instances are updated, and this process is repeated until the entire system is running the new version. TLDR. Blue-green is great for apps requiring instant rollback. Canary is ideal when you want real-world testing on a small subset of users before full deployment, and rolling is best for large-scale distributed systems like microservices or Kubernetes clusters.
Baby, you got something in your nose. Sniffing that K, did you feel the hole?
If you learned something new in today's video, please feel free to hit the like button or subscribe for more future content like this. And as always, thank you very much for watching this video, and happy coding!